During any planning process, planning data must be protected against changes, especially once a plan has been approved. Data slices provide the mechanism to enable this locking and can either be manually set based on an exit variable or set through an exit class specifically for data slices. In our case, we're going to configure a process whereby the planning administrator can set the data region to be locked via a query, and upon saving, an exit class will set the data slice parameters for the info provider. We will lock the volumes planning ADSO TVOL 820 by version and sales organization. The steps required to create data slices based on an input-ready query is as follows. Create the input-ready query and related objects, create the ABAP class to process the data slices, and then configure the data slices. We will then create an AMDP class to process data slices as an improvement over the ABAP implementation. Before we start with the configuration, let's see where we're heading. So my input-ready query for data slices displays the version and the sales organization. And if I look at my planned volumes by material group input schedule, we can see that we can save data. So if I change the value here, I can save it. If we want to lock a data slice, I go to version 100 for sales org 1710 and I simply enter it a 1 and save. And then when we go back to our query, we can see that this query is locked. And if I try to change the value now, I cannot save the data. So data slices locks this intersection against changes. The configuration of the input-ready query is in the attached configuration guide. So let's jump straight to the class. As for characteristic relationships, the class must inherit from a base class. And in the case of data slices, it is CL, RSPLS, DS exit base. Next is the coding of the data slice, and the method IF, RSPLS, DS methods is protected must be redefined. Next we're going to look at the code for the method I is protected, and when we look at the signature for the method, we can see that there's a single import parameter called IS data, and this is a structure containing the version and sales org that we're evaluating for the data slices check. Now, if I go to my input schedule for data slices, we can see that I've set version 100, sales org 1710 to indicator 1, meaning that it is locked. And if I go to my volumes planning query and I execute my copy function, we can see that it breaks at my IS protected method. Now let's look at the values within. So first I do the assignment of version and sales org to field symbols, and we can see that 1710 and version 100 has been assigned. You can see that the values are being passed. Then from the data slices DSO, I select all the records for the sales org version where the lock indicator is 1. And if I step over and over, we can see that size sub RC is equal to 0, which means that it found a record, and in this case we set the no input export parameter to ABAP true, meaning that the record will be locked. Now if I continue execution, we can see that it breaks several times. It breaks for every single record that's being copied. And this obviously leads to inefficiencies, because if you've got huge volumes of data, it executes the code for every single record. We can now configure the data slices for our info provider TVOL 820. So we go to the info provider in RS Plan, go to Edit, go to the Data Slices tab, and we create it. So we're simply going to describe it as rule 1, and we have the type as exit, and the name of the class is the class we just created, ZCL-Vol-DS. We then go and create or select the fields involved in the checking of our data slices, which is sales org version, and then we save. Now let's look at our AMDP method. Now the configuration guide contains the detailed steps to set up the class as well as the method, and I'm just going to highlight one or two aspects thereof. We have to implement the interface IF RSPLS DS exit HDB, create our types, which consists of sales org version, so the fields that needs to be checked, in the method getSQLScriptInfo, we specify the name as the class, and then the method AMDP is protected. And then in our method AMDP is protected, we specify its HTTP procedure using our ADSO for the data slices values. And then the code does virtually the same as it does for ABAP. However, you can see there's an export parameter ET_data, which is a table, as well as an import parameter IT_data, which is also a table and differs from the ABAP implementation in that it's not a structure. Now let's execute our planning function. And again, it breaks. And this time it breaks in our AMDP. And I'm going to step over. And we can see that ET_data now contains 740 records. So instead of looping through each record, it does the ET_data selection in a single step. So all our lock records is contained in this table. In this chapter, we predicted planning data against changes by implementing data slices. Two implementations were created, an ABAP implementation and a SQL implementation. In the next chapter, we're going to look at master data planning.